As we talked about previously, this section is not to be tested over, but it's to help you understand the sections I am testing over. So sort of a physical frame of reference for quadratics. So we'll start with the idea of quadratic function in standard form. A function in this form, notice here we have some squaring going on. So we have ax squared plus bx plus c, so y equals all that. Obviously a isn't 0 because multiplying by 0 would knock out the squaring here and just make this bx plus c, so it'd be a standard linear function. Again, examples of what that looks like. Things like y equals 3x squared plus 2x minus 4. That's a quadratic function in standard form. Should also mention the graph of those are going to end up being something like this. It's a parabola. So that next definition here is parabola, the graph of a quadratic function. And I've included a couple here for you. If I were to graph x squared plus 4, looks like this. If I were to graph negative 2x squared plus 4, it goes upside down. That's the negative part in front here, flips it over. Plus 4, we'll talk about this. It moves the vertex up and down. And we'll talk about what I mean by vertex. The axis of symmetry. So you'll notice these things look symmetrical, right? They're not. They don't go like this. They're nice and even. They're symmetrical. And so anyway, we have to find an axis of symmetry. It's something very useful when we go to graph them. And there's a formula for that. The line that divides a parabola into two matching halves. That's taking the b here, in this case the 4, and putting it over, and the opposite of that, and over 2a. And that gives us the line, the x coordinate, if you will, for the axis of symmetry. So to put some work to it here, again, we know a, b, and c. In this case, a is 1, b is 4. So the opposite of b is negative 4, 2a, so 2 times 1. So x is negative 2. And we all should know by now what the graph of that looks like. But again, on the one we have here, negative 2. Whoops, that's off just a hair. Let me fix that. There we go. Negative 2 is right there. So the line, that line there, x equals negative 2, is the axis of symmetry for this parabola. And I bring that up as being important not only for the fact that it helps you to graph, and I'll show you that too, but it also helps us to determine where the lowest point, or if it's flipped over, the highest point is along that parabola. So the word I mentioned, the last one, I mentioned the idea of vertex, the highest or lowest point. So in the highest or lowest point of a parabola is its vertex. So in this one obviously has a lowest point. This one has a highest point. And to find that, it's nothing more than using the formula we just had for axis of symmetry and substituting that into the parabola to get the y-axis. So it'll give you the exact point. Again, it's a minimum point down here and a maximum point over here that we're looking at. So again, minimum if a is greater than 0. So when we have that equation where the a is not negative, the vertex is the low point. And again, to find that, you merely find the axis of symmetry using the formula we just discussed, substitute it back into the original equation to get the y coordinate as well. So to exactly where that point is. Now, when a is less than 0, the parabola basically flips over. At this point, we have a maximum point. And again, same thing. Use the formula. Find that axis of symmetry. Substitute that x-coordinate back into the original equation. And that'll give you the y-coordinate, so you'll know exactly where that maximum point is. Okay, so to find that maximum or minimum point, almost couldn't spit it out there. In this case, obviously, it's a minimum point, down here. To find that, we first find the axis of symmetry. So I got a set of steps here for you. And again, that's just that formula. I identified a and b there for you. Please remember the sign goes with it. That's extremely important. So in this case, our x-coordinate equals the opposite of b, so the opposite of negative 20, right? It almost made a negative 20. Over 2 times a, in this case, a is 5. I'm going to make that look a little bit nicer. negative 20. There we go. And so that should be pretty straightforward stuff for you. That's obviously 2. Then I take that 2 and I substitute it back in for x everywhere in the original equation. So y equals 5 times our 2 squared minus 20 times our 2 plus 15. So again, substituting back in that original equation. Obviously work this out and find that y is then negative 5. So the coordinate of our minimum in this case is 2, negative 5. And you can see that on here. That's pretty straightforward. That's obviously where that's at. So nothing more than that. Another formula for you. Learn it, whatever, however you want to use it.